In this session, we'll be talking majorly about how exactly equivalent Chomsky normal form can be created from the given context-free grammar. As we all know that a grammar is said to be context-free grammar if all the productions of the grammar are having this particular form, where A can be any possible variable from the given variable set, and this alpha would be combination of Vn, which is your variable set or non-terminals, and sigma, which is input alphabet or terminal set, so combination of it. So if all productions of a grammar are having this particular form, then such a grammar will be referred as a context-free grammar. Now, to convert it into Chomsky normal form, we need to first understand what are the different ways or what are the different mechanisms that we need to apply for considering or converting a given grammar to Chomsky normal form. So for that purpose, first of all, let us try to see what are the stages. A grammar is said to be, say, grammar CFG. G is in CNF if and only if all of its productions are having some form which will look like, for example, either A gives BC or A gives small a, where A, B, C are belonging to variable set, and here A is said to be any symbol from sigma. Now, if we have been given a context-free grammar, in that case we definitely will require now to find out whether the given productions are having this particular form or not. So for that purpose, let us try to see what is the mechanism we need to apply rather to convert a given context-free grammar to Chomsky normal form. So first stage would be what? Like first step that we have to always see, check whether the given grammar contains null productions and unit productions. Check whether given CFG contains null productions. So if they are, then we have to convert them as without null productions. So when we convert a grammar from having null productions to having not null productions, in such a case there would be some productions which would be generated, and they are called as unit productions or chain rules. Now we have to first consider that if given grammar contains null productions or unit productions, we have to first create a grammar which will not have either of these two. So ultimately we would be getting some grammar. Suppose we have been given G, after applying null and unit production grammar, say suppose we got G dash. Now we have to use this G dash to convert in CNF form. So next stage would be, now we have to control the terminals which are occurring towards right side of the production that we got, production set that we got with G dash. So for example, if I have some grammar which is like this, for example, which one production say like this. So now I have to find out, do I have any terminal occurring towards right side? If it is, then I have to introduce a new variable, for example like CA, and then I will rewrite this production as gives AA as gives CA and A. So this would be our second stage. Third thing would be, or third stage would be what? We have to control how many variables would be occurring towards right side of the production. So suppose our production is something like this, AAB. So in this case, if you see, there are three symbols occurring towards right side. So by applying this second rule, we will convert these two like this. So S gives CA, A, CB, where CA gives A would be added by S and CB gives B would be added by S. Now we have to control the number of variables that are occurring towards right side. As per CNF rule, that what we saw earlier was either there can be one terminal or there can be two non-terminals. So in such a case, we have to control now occurrence of number of variables towards right side. So how we will convert this production as? So we will take S as, suppose my production is CA-A-CB, I will take CA-C1 and C1 I will write as A-CB. So if now I see these productions, here these are the productions that I got from the given production that I do have. So from this particular production I created these two particular productions, and for these terminals that are occurring towards right side, for each of the terminal that is occurring, I have introduced these two new productions. So ultimately, when I see particularly this particular production set, or this production rather, this production is converted to new 4 productions that I can see over here, which are generated accordingly. So we will take one example now where we will see how exactly this is to be done. So let us say that we have been given some grammar which is a context free grammar without null production and without unit production. Suppose I have been given grammar like this: AA, BB. A gives, now suppose AA or B, and B gives suppose BB and A. Now if I carefully see, this grammar doesn't follow the norm that a normal form should have, because we said that a grammar is said to be in CNF if its productions are like this: A gives BC, or a variable gives a terminal. So if I see over here, only 2 productions are there from the given example which are following this norm. For example, A gives B. So A gives B and B gives A are in the required form of Chomsky normal form. Now my task is to convert this production, this one and this one to the required form. So how exactly I am going to do is, like as I do see here, that on the right side of either of these productions there are some terminals occurring. So what I will do, for each of such terminal I will introduce a production by introducing 2 new variables, as I do have only A and B. So for A I will introduce CA and I will write CA gives A. For B, which is another terminal that I do have, so I will introduce CB, which gives B. Now what I need to do, I need to rewrite each of these productions. So I will pick production one by one. So let us consider that I have S gives AA. Now if I replace this A by CA, so ultimately this production can be written as CAA. Now if I see here, this is a variable which was introduced by me, this was my earlier variable. Now these are 2 variables, and according to the rule I can see that 2 variables are occurring towards right side. So this production is in the required form. We already have seen that these 2 productions which were given in the grammar are already in the required form. The productions that we introduced are also in required form because the variable is giving terminal to us. Now the way that we applied this particular rule to convert S gives AA to S gives CAA, similarly we will apply that rule for each of these productions. So let us take next one as S gives BB. So what will happen is, as B is occurring towards right side, which itself is a terminal, so we will introduce a variable which was introduced by us earlier. So we will take that variable and we will rewrite that production like this. So this S gives BB would be written as S gives CBB. On the similar line, if I take next one like A gives AA, so this would be written as A gives CAA. Now if I see next production, B gives BB, so this would be written as B gives B and CB. So ultimately from the given grammar, these were not in the required form. So what are the productions that I have created now? Each of these productions are now in the required form. Earlier I have been given 6 productions rather. Now after applying this conversion rule, I do got 1, 2, 3, 4, 5, 6, 7, 8 these new productions. So this is how you convert a given grammar to Chomsky normal form. Now in this case we luckily had only 2 symbols towards right side. Let us take another example where there would be multiple symbols occurring towards right side. So let me take another example where we will consider now more than 1 symbols occurring or more than 2 symbols occurring towards right side. So for example, I have a production S gives A, capital A, small v, and then small a, capital B, and 2 consecutive B's. Now suppose I have for A one production which is like A gives AA and C, and for B I have BB and say C. Now this is the one, this is the production set that was given to me. Now what I need to do is, this grammar is to be converted by me in the equivalent normal Chomsky normal form. So for that purpose, let us try to see from the given production set how many productions are of the required form. So as our required form says, a variable should give a terminal, or a variable should give at most two non-terminals. So accordingly, if I see, I can see that A gives small c and capital B gives small c. These two productions are in the required form. So I have not to apply any kind of rule now to convert this. So I will consider now remaining productions. So let me first pick, for example, this one. So I do see that in these productions, rather, I have A and B occurring towards right side of each of the production, or most of the productions. So what I will do, for each of those terminals, I will introduce these two variables called CA and CB, where they would be giving me directly terminal. So this was introduced by us for controlling, or for removing these terminals which are occurring towards right side, so as to bring the given grammar into required form. So we introduce these two, and if we see over here, these two are again in the required form, a variable giving a terminal or non-terminal giving a terminal. So now what we will do, we will rewrite the existing production by introducing these two respective new variables which were introduced by us. So let us pick one by one each of the productions. So first production, let us pick as S gives A, B. Now we will replace each occurrence of A and B over here by newly introduced variables. So the production can be written as CA, A, CB. Now if we see, we wanted now two variables here towards right side, but one can easily find out that there are three variables. So how we will convert this? So we will take this leftmost symbol, a leftmost variable as it is, and we will introduce a new variable called, say for example, C1. Now as we have here two values, so we will write C1 gives A, CB. So ultimately, what are the production that was given to me as S gives small a, capital A, small b, that is converted to S gives CA, A, CB. Then in turn again what I did was I introduced one new variable called C1, and I rewrite it as S gives CA, C1, and C1 gives this remaining part. So ultimately this production was converted by me, and I do got now these two new productions along with these two newly introduced productions for the terminals. Now let us pick this next production. So next production is S gives A, B, small b, small b. Now as we have introduced already CA and CB for each respective A and B which is occurring towards right side, so we will replace them by newly introduced variables. So we got CA, B, CB and CB. Now if we see here, in earlier case there were three symbols, now we have total four symbols. Now we have to control this so that for every production which we will be converting should have at most two variables toward right side. So this can be rewritten as CA, say let me introduce now C2. Now what is remaining here is B, C, B. So I will write first C2, then the next symbol that I do see here, I will write that B, which is my leftmost symbol in the remaining string of all non-terminals. So I will write B, I will introduce one more symbol or a non-terminal called C3, and now remaining is CB, CB, which I will write as C3 gives CB, CB. So ultimately what I did was, I have been given a grammar which was containing a production S gives one terminal, then non-terminal, then two consecutive terminals. So ultimately I converted it to by replacing each occurrence of terminal by newly introduced variable, and then I controlled number of variables that are occurring towards right side. So by introducing some new variables. So what I did was I kept this leftmost symbol as it is, CA, and for this remaining thing I considered C2. Now as C2 is containing these three, so what I did was I picked leftmost symbol as B, I kept that leftmost symbol as it is, I introduced one more symbol or non-terminal which is C3, and whatever was remaining I exactly added that over here. So this particular production was converted by me in the required form, and I ultimately got these three new productions for that as an equivalent for this particular production. So we already converted this one, we already converted this one. Now let us talk about these two. So we already have added two productions for A and B. So this A can be written as A gives CA and A. This CA was introduced by us earlier in this case. So I replaced that A occurrence by CA, and for the same case I would be having now B gives BB, so CBB. So now if I see, This was my given production set 1, 2, 3, 4, 5, 6, which was containing 6 productions. For these 6 productions, I have created an equivalent grammar in Chomsky normal form, now which is containing these productions now. A gives C, B gives C. Then newly introduced productions by me for the terminals that are occurring towards right side along with non-terminal. So CA and CB, which I introduced as another productions. Then I picked each of the production respectively, which is having combination of terminals and non-terminals. So for this one, I got these 2 new productions. So for the next one, I got these 3 new productions. And for these 2 remaining, I got these 2. So now, as a result, I do got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, nearly 11 production, which are now in the CNF. So this is how you convert a grammar from the given form of CFG to an equivalent Chomsky normal form.